and welcome back to Tall, also known as Teach as We Learn. Today I'm going to be teaching you about dilations. So let's begin. So I know this seems really disorganized and I've written a bunch of stuff on here, but basically these are like the key components which I'll be going through. And then I also don't want to just, talk off the screen. So that's why I just wrote the key components. But before we begin, what is a dilation? A dilation is a transformation that either reduces or enlarges, meaning that it either goes smaller or larger than the original figure. And a special thing about dilation is that this happens proportionally, meaning that each side or each point of the triangle or any shape would be dilated with the same scale factor. And that leads to scale factor. And basically a scale factor basically describes how much of it has been dilated. So how much has the image changed? And then we have a formula of image over pre-image, which I'll go more in depth later. But then we also have basically enlargement and reduction. Basically, an enlargement is if its scale factor is greater than 1, meaning that since the scale factor is greater than 1, the image will get larger. So it will be dilated, a larger way. Whereas if the scale factor is smaller than 1 but larger than 0, then the image would be dilated smaller, right? The image would shrink, get smaller. If the scale factor is 1, like exact 1, then that means that the image is the same or like the same size. And then we have a little formula, and basically what we're saying is that scale factor multiplies both the x coordinate and y coordinate. So this is the formula for dilations. So now let's begin with actually seeing an example of a dilation. So here we have a scale factor of 1/3. And this is our pre-image, meaning that this is our original figure, right? This is the first figure which we initially had. And this is our image, right? Pre-image to image. This is what we want to be dilated. And in this instance, we want this to be dilated by the scale factor of 1/3. So what I would simply do is take my pre-image points and multiply them 1/3. So here we have 0, 6. That was not a good disease. And I'd use this formula. So K, which represents our scale factor, right? So we do 1/3 times 0. And that's 0, right? Because anything multiplied by 0 will always remain 0. Then 6 times 1/3. So if I, maybe write that out, is 2, right? Because 6 times 1 equals 6. And then I put a little 1 underneath because 6 divided by 1 is 6. And 1 times 3 is 3. And 6 divided by 3 would be 2. So 0, 2 would be one of our first points. And if I see here, yes, 0, 2 is a point of our dilated image. Then I do the same with the rest of these points. So we have minus 6, minus 3, and I would multiply that by 1/3. So I could just write 1/3 here, or I could also write 1/3, 1/3 here. 1/3 times minus 6 would be minus 2. And 1/3 times minus 3 is minus 1. So -2, -1 is a point, and yes, it most certainly is. And then I can do the same with this one. I can just, turn this negative to positive, right? Because they're the same. 6 just positive in this one. They'll get the same results, but 2 would be positive. And is it 2, -1? Yes, it is. So this image has been properly dilated, and even if we didn't have all these points already, that's how we would get our dilated image with a scale factor of 1/3. Next up, we have an example of an enlargement. So we're going to be considering this red triangle as our pre-image. So red triangle is our pre-image. and our orange triangle as our image, right? And we want to have it as a scale factor of 2. So I'm just going to write k equals 2, right? Because actually teachers do that, right? They don't always have to write scale factor, because when you're initially taught the formula, it's k equals image over pre-image. So just keep that in mind. So let's begin. Again, we'll find our corresponding, points. So 0, 4, it's at the left side corner, so that would mean 0, 2 is our left side corner, right? Both of them are left side corner. Then right side corner would be 6, 4 here and 3, 2 here. And then our vertex is 2 minus 1, I believe. 3 minus 1 and 6, 2. Right? Okay. Yeah. Sorry. 3 minus 1 and 6 minus 2. I'm so sorry. Okay. Those are our points. And then again, we're just going to make sure, right? So if we're given this, we would just multiply by 2. So 0 times 2 is 0, but 2 times 2 is 4. So is our coordinate 0, 4? Yes, it is. So that's a check. 3 times 2 is 6, and 2 times 2 is 4. So our right-hand corner should be 6, 4. That's indeed. And then 3 minus 1, 3 times 2 is 6, and minus 1 times 2 is minus 2. And is that our point? Yes, it is. So we can definitely see that this triangle is actually been dilated. And since pre-image to image, right, got multiplied by 2, our scale factor is 2 as each side got multiplied, or point got multiplied by 2 exactly, proportionally. So this is an enlargement as the image got larger from pre-image to image. And this one was a reduction because it shrank from pre-image to image. So that's pretty much it for dilations. If you have any questions, please let me know. I think we're almost done with this unit. I think we might have another video on it, but I think we're almost done. So this is it, and we'll soon begin on our next topic. See y'all.